Hi everyone, it's Sorkin. Today we are going to implement a hash map without using libraries. So first let's take a look at what is the hash map. Hash map is a data structure where we are storing key value pair. So for example, in this case we are storing 4 as a key and the corresponding value is 8. We are storing 5 as a key and the corresponding value is 10, 9 and 18 and so on. So how we are exactly going to implement the hash map? Let's go over it step by step. As a first step, we are creating an array of node where node is a linked list. So class node has 3 fields. The first field is a key where we are storing our key. Next one is a value where we're storing our value, and the next, which is pointing to the next node because it's a single linked list. So HashMap has 2 functions, put and the get. Put is where we are adding key and value to our HashMap, and the get where we are getting our value by the key. So first let's take a look at the put function. So what we do here is we are adding a key value pair 3 and 7. So first thing that what we do, we are taking the modulo of key to size. In our case key is 3. 3 to 6 gives us 3, which means that we are going to store our, so we are calculating our hash, and our hash is 3, so which means that we are going to store our key value in the 3rd cell of our array. In reality, we are using much more complicated way to calculate a hash code, but for the sake of simplicity, in this case, we are just taking a modulo of key to size. Let's take another example where we are adding key value pair 4 and 81. In this case, again, we are taking the modulo and it's 4, so we are storing that in 4th cell for key value 4 and 81. And the next one is we are adding 9 and 19. We are adding 9 and 19. Again, we are taking the modulo to size and gives us 3. So, but we already have a key, but we already have a node in the 3rd cell of our hash map. So what we do here, the first thing that we do is we are comparing our current key value and the key value that we have in the cell. So we are comparing 3 and 9. They are not equal. If they are equal, it means that it's the same key, so which means that we are just going to update the value. So let's say that we are adding 315, so we are calling put function with the keys being 3 and the values being 15. So in that case, we are going to just update the value. So instead of, we are going to update 7 to 15. In our case, they are not equal, which means that it's a new key value pair, and our hash code is the same. This case is called a collision. So we have a collision because in one cell we need to store two key value pairs. So what we do is we are creating a new node, and our current node is pointing to our new node. That's why we are using a single linked list here. So let's go over our steps one more time. The first step that we do here, we are calculating a hash. Again, the calculating a hash function is much more complicated, but in our case, we are simplifying that. It's we are taking key modulo to size. Why modulo? Because in that case, it allows us evenly distribute nodes to each our cell. So the next one is we are finding a cell where to add our node. So for example, in our case, let's say 3 and 7, right? We take the modulo and we are storing that in the 3rd cell. And the next one, if the node already exists in that cell, we are adding it as we are adding our new key value pair as a last node in that single linked list. So what's the time complexity of the hash map? Time complexity of a hash map is usually of 1, but in case of, let's say that our hash code function is implemented not optimal, then in that case we are going to have in one cell too many nodes stored in just one cell. We will have too many collisions. In that case, in the worst case scenario, in order to find our key value pair, in order to find the value by a key, we need to go over each node. So in that case, in the worst case scenario, our time complexity is going to be of n. First thing that we do here, we are initializing our array with the size of 10,000. So the next one is that we have a class node, as we have seen earlier, with the fields of key, where we are storing our key value, and the next, because it's a single linked list and it's pointing to another node. Let's take a look at our put function first. In our put function, what we do is we are receiving key and value, which we need to store in the hash map. The first thing that we do, we are calling hash function and passing our key. And as we have seen earlier, our hash function is simply modulo of key to size. So in this case, modulo of key to size gives us our index where we are going to store our key value pair. So we are checking that if in our array, if that in that index, if we don't have any node, then in that case we are creating a new node and setting that to that index. If we already have node, right? If we already have node and it's not empty, then what we do? We are going over our nodes, and we are at each step we are checking if the current key, whatever the node is, right? So if the key of that node is equals to our key, if that equals, so which means that we have already added that key earlier, and now we are just updating the value. So we are updating the value and we are setting that to our current value, and we are simply returning here. If it's not, then if we don't have any nodes left, so which means that we are at the end of our single linked list, and we are breaking the while loop. So what we do is we are adding a new node, which is our current next, pointing now not to null, it's pointing to a new node that we are adding key and value. So how about the get function? In the get function, what we do is, again, we are calling hash function with our key, and for the what we do is we are taking the current node by that index, and we are going over our single linked list until we find our key. If we find our key, then we are just returning the value. If we cannot find any key, if the key does not exist, then in that case we are just simply returning -1. So how about the remove function? In the remove function, so we are receiving a key, and we need to remove our node by that key. We need to remove our key value pair by that key. So first thing, again, we are calling our hash function. We are finding an index, and we take the node from the first node from that index, right? The first node from our hash map. And if that node is empty, which means that there is nothing to remove, we are just returning. If our current key is equals to key, so what we do is which means that there is only one node. So what we do is our map. So our now map index points to not the current node but to the next node. So for example, let's say that we have two key value pair, right? 3 and 11 and the 5 and 10, and we need to remove 3, the key value pair by key 3. So if we are removing key 3, so in that case we are just our map index points not to the 315, 311, but to 5 and the 10. And if the current key is not equals to key, so what we do is we are setting previous to current, and we go over our single linked list until we find our key. So for example, let's say that in our single linked list, in the same cell, we have 3 key value pairs, 3 and 11, 5 and 10, and 8 and 20. And we need to remove the key with the key 5, right? In this case, if we need to remove the key 5, so what we are doing here, we are this node, right? 3 and 11. 3 and 11 is pointing to now not to 5 and 10, it points to the 8 and the 20. So we go over our single linked list until our current key is equals to our key. So if we find that, then what we do is our previous now equals to current, right? And the current is equals to our current is equals to current next, that's what we do at each step. And if we find our key, our previous next now points to our current next, which means that in this case 3 and 11 points to the 8 and 20. What's the time and space complexity of this solution? The time complexity is that put, remove, and the get, it's of 1, so which means that it's constant. But again, as I mentioned earlier, if in one cell, if our hash function, if it's not optimal, which means that we are going to store in one cell, the number of the nodes in one cell would be too many, which means that it would be the size of our, basically, that the all nodes that we are adding to our hash map. So in that case, in the worst case scenario, our time complexity is of n if we have too many collisions. But the space complexity is basically of n. It's the number of nodes that we are adding to our hash map. Java implementation is identical. So first thing that what we do is we are creating an integer size, which is the size of our array, and we are creating an array node, let's call it map, where we are going to store all of our nodes. And we are creating a node class with the fields of key, where we are storing our key value, and the next, which is pointing to the next node because it's a single linked list. And we are initializing our my hash map, where we are creating a new array with the size of our hash map. So what we do is let's first take a look at the put method. So what we do is we are receiving two key and the value pair, and the first thing that what we do is we are calling our hash function. Our hash function is simply the module of key to size. So we are finding our index, and the first thing we are checking that if in that index we have a node. If we don't have any nodes, which means that it's the first node, this is the first key value pair that we are adding. We are adding that key value pair to our hash map, to that index. If it's not the first key value pair, then what we do, we are taking the first node, and we are going over our single linked list. And at each step we are checking if our current key is equals to key. What it means? It means that we have already added that key value pair earlier. So we are updating that just the current value to value, and we are returning because we have already, we just need to update our value. If it's not, then we are going until the end of our linked list. Then we are going to until the end of our linked list, and we are adding the last node. We are adding our key value pair, right? Our last node is pointing to the, instead of null, it's pointing to our new node that we are adding. How about the get function? In the get function, it's the same. We are calling a hash function with the key, and we are taking from our map we are taking our current node, whatever our current node is there. We are checking if we are going until we are going over our single linked list, and we are checking that at each step. If our current key is equals to key, if we find our key value pair, we are returning that. And if we cannot find it, then in that case we are just returning -1. How about the remove method? So in the remove method, we are removing our key value pair by the key. So what we do, again, we are calling a hash function. We are taking our index, we take our first node, and we are checking that if our first node is equals to null, which means that there is nothing to remove, we are just returning from that, from the remove function, or from the remove method. And if there is, then we are checking that if our current key is equals to key, then in that case our map index is pointing to not our current node, but to the next node. So what it means? So for example, let's say that we have two nodes here. We have 3 and 11 key value pair, and we have 5 and 10 key value pair, and we need to remove the key value pair 3 and 11 by the key of 3. So what we do is our map index now pointing to the 510 instead of the 311. So which means that now there is we don't have this key value pair in our hash map. If it's not the first node, then what we do is we are going over our single linked list, and until we find our key value pair. So for example, let's say that we have in our one cell we have 3 nodes. We have key value pair 3 and 11, 5 and 10, and 8 and 20, and we need to remove the key value pair 5. We need to remove the key 5, which means that the key value pair 5 and 10. So what we do is we are going over our array. So we are maintaining our previous and we are maintaining our current. So what we do is we are going until we find our current is equals to current key is equals to key. For example, in this case, let's say that the current is 5. It equals to our key that we want to remove, to 5. So in that case, our previous next, which means that the 3 and 11 next, right? It points to the 8 and the 20. So 8 and 20, which means that we are removing from the chain, we are removing from the single linked list this node 5 and 10. So what's the time and space complexity of this solution? The time complexity is for put, remove, and the get. It's of 1 because it's a hash map, and we are fetching our value by the index. And if we have too many collisions, so which means that in one cell we are storing too many nodes, in that case we need to go over each node, and the worst case scenario, our time complexity is of n, and the space complexity is simply of n because we are storing each node. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.